Good morning, all. Good morning, students. Welcome to Telangana State Model School webinars. Firstly, I want to congratulate all of you for adopting mathematics stream. As all of you know, mathematics is the king of all subjects. To take you into the world of mathematics, coordinate geometry, today we have with us an eminent mathematician, a distinguished speaker, and also a courageous administrator, Mrs. N.Sreedevi, Principal, Shankarampet R, Medak District. In the previous class, she had dealt with transformation of axis, part 1, with interesting numericals. And today, she's going to deal with transformation of axis, part 2, that is rotation. So children, it's a very interesting class. So listen carefully, note down all the points. And if you have any doubts, you can post. And I welcome you, ma'am. It's an honor to introduce you. And please start your session.
Thank you, Manjari Madam. Namaskaram, everyone. Welcome and a pleasant morning to all of you. Dear students, we are going to continue a journey of transformation. You all are aware that we have started with translation of axis from the chapter transformation of axis, and today we are going to deal with rotation of axis and a combination of rotation and translation. So, without wasting much of your time, I will start your session. Here we go, students, with rotation of axis in the beginning. Then we will also discuss about translation come rotation, rotation come translation of axis for today. I hope you remember what we have done in earlier class. We have just shifted the axis without changing the direction and called it translation. What was the change? The origin was shifted from 0, 0 to some other chosen point. Then we have also found out how the coordinates of the point change with respect to the new system and how the equations of the curves also undergo transformation due to translation of axis. Without changing the direction of axis, we have shifted the origin. Now let's see, without shifting the origin, what are we going to do? What we are going to do, this is a point xy with respect to the existing original coordinate system. What happened? We have shifted the axis in anti-clockwise direction, making an angle, some angle, let's call angle theta. So in the new system, the coordinates of the point are capital XY, as we have done in earlier class, and original coordinates are small x comma y. Now when we have rotated the axis through angle theta in the positive direction, isn't it? Anti-clockwise direction is a positive direction. So the angle between these two axis is same as this. That is also theta. Now let's see. See, this is our new axis. I have just blurred the old axis. Now what is our reference point? The new axis. How, as a result of what we got this new axis? By rotation of the axis through an angle theta. Now let's see that in detail. See, what is this value now? What is this? This is a perpendicular that I have drawn from the new coordinate point to the original axis, right? And called it L. Call it L. What is OL? Small x. Now, when I am drawing again a perpendicular to the new axis and called it M. What is O to M? The capital X. Am I clear, children? O to L, you all know that is small x, and O to M is capital X. Now, let's drop a perpendicular from M to the x-axis, original x-axis, and call it Q. And this point is P, we already know that. And drop a perpendicular on PL from M and name the foot of the perpendicular as N. I repeat, PL is perpendicular to the original axis. PM is perpendicular to the new x-axis. Then from there we have drawn N perpendicular to PL and MQ perpendicular again to x-axis. Why did we do so? We know O to L is x. We know L to PL is, what is this? PM is O to M is capital X, O to L is small x. OL is small x, OM is capital X. What is PL? That is Y. According to original system, that's why it is small y. And PM, that is according to the new system, new axis, it is capital Y. Now, let's see what we can do with this. See, we're taking the same diagram and trying to take what is x. X is nothing but OL. How do I get OL from OQ? If LQ is subtracted, we get x. X is equal to OL. That's what is written here. OQ minus LQ. OQ minus LQ. What is OQ? What is LQ? Let's find out. Can we find OQ minus what is LQ is equal to NM? Isn't it? MN or NM? That's a perpendicular that we have drawn from M, and this is equal to the same distance LQ. Now, how do we find MN? How do we find OQ? See, this is a triangle. OQM is a right triangle. Children, do you remember what have you learned in your trigonometry of 10th class, class 10? In a right angle triangle, OQM, if this is angle theta, NM or OQ, do you find OQ here? Yes. What is OQ? Is it opposite to angle theta or is it the adjacent side? Adjacent side. Now, what do we know in this diagram? We know OM. How much is OM? Capital X. So by taking adjacent, and what is the side? This is hypotenuse. Adjacent by hypotenuse gives us what trigonometric ratio, students? You're right. Cos theta. Cos theta is equal to adjacent by hypotenuse. You recollected? Okay. OQ is OQ by OM. If I bring OM to the other side, OQ is equal to OM cos theta. Why am I taking all this? In order to substitute OQ here, I am taking it as OM cos theta because here we know an angle which is through which the axes are rotated. So let's see. That is equal to OM cos theta minus NM, isn't it? Now, what is NM? Let's see the diagram. What diagram I have taken? See, this is the small triangle PNM. I am taking it for your clear understanding. This is PNM and right angled at N because that's a perpendicular. PM is the hypotenuse and NM. Where is the angle? Angle is here, theta. Angle theta is here. Then what? How come this angle is theta? See, when we have drawn perpendicular from P to original x-axis and P to the new x-axis, the angle between the axes is same as angle between the perpendiculars that are dropped from the point. That's why if this angle is theta, this angle will be theta. Now this theta has an opposite side as NM. We are looking for NM value. So opposite side and hypotenuse, how they are connected? Children? Sine theta, right? So sine theta is equal to opposite by hypotenuse. Opposite is NM, hypotenuse is PM. Now, if I take NM like that only and bring PM to the other side, NM is equal to PM sine theta. Let's write in place of NM, PM sine theta. So, I hope this is clear, students, right? Done. What is x now? OM cos theta minus PM sin theta. Do we know what is OM? Do we have here? O to M, that is capital X. And what is PM? Capital Y. So can we write X is equal to capital X cos theta minus capital Y sin theta. So children, do you see this? There's a relation between the new coordinate, old coordinates and the new coordinates. Similarly, Y is equal to, if I take Y, small y, from origin, what is Y? O2, how much? Till here. What is that point? PL, isn't it? PL is small y. That is equal to PN plus NL. P to N plus N to L. If you add, you are getting PL. Same. PL is similarly. What is PL? PM cos theta. What is OM? NL, OM sin theta. Similarly, how we have done taking the triangles, if you do, you'll get that. So y is equal to, what is PM? Y, OM, X. Y cos theta plus X sin theta. These two are the important relations that we have when the axes are rotated through an angle theta. The relation between original coordinates and the coordinates according to the new system are given by these two relations. Now, how do we remember this cos theta, sin theta? Xy is equal to x cos theta minus y sin theta. Then y cos theta plus x sin theta. Okay, how do we remember? Let's see. This is what we have done, isn't it? Now, if we know this, can we find capital X and capital Y when we have to replace? Let us see. I'm taking x into cos theta. What is x into cos theta? What is the x value? X cos theta minus y sin theta. Multiply that with what? Cos theta. Cos theta into x cos theta minus y sin theta. What do we get? We get x cos into cos cos square theta minus y into cos into sin theta cos theta. Now what is the value of y? Y is equal to y cos theta plus x sin theta. What am I taking? Y into sin theta. So multiply y, original y, with sin theta. Y into sin theta cos theta, y sin theta cos theta. X into sin theta plus sin theta, sin square theta. So y sin theta is sin theta into x sin theta. I am just rearranging the terms and writing here x sin square theta and writing this term in the second place. Let's see now if you are going to uh, simplify this. Don't you think these two will get cancelled? Minus y sin theta cos theta plus y sin theta cos theta. Oh, they get cancelled. Then when I am adding this, what do I get? X into cos square theta plus sin square theta. X cos square theta plus x sin square theta. What is that? X into x of cos square theta plus sin square theta. Do you remember what is cos square theta plus sin square theta? First identity that you have learned in your class 10. It is equal to 1. So x into 1 is x. Capital X is equal to x cos theta plus y sin theta. What is that we are getting now? We are getting the new coordinate when you know the old coordinates. Here we are getting original coordinates when new coordinates are given. Let's see. R, see, capital XY is, this we have found already, x cos theta plus y sin theta. What did you get? You got it as x. Similarly, if you take minus x sin theta plus y cos theta, will you get y or not? Capital Y or not? Who has to do it, students? It's you. Correct? You please check. You please take minus x sin theta plus y cos theta and check whether you get y or not. You will surely get, I think. But I got it. You check it for yourself and see that. Then, now how are we going to remember this? Oh, x cos theta minus y sin theta are capitals. Then y cos theta plus x sin theta are original coordinates. When you want to find new coordinates, then this is the formula. Oh, let's look for some simple way of remembering these two formulae. See, I'm going to take capital X, capital Y, new coordinates, original coordinates x and y, and then take a tabular form. What am I going to do here is see cos theta minus sin theta, cos theta. This is an easy way of remembering. Even during any objective type problem, or even during your IP examinations, or any kind of problem solving, you please remember this table. It's not that you don't have to by heart it. See, there's a logic: x, y, capital coordinates, that is new coordinates, old coordinates. What is there? Just remember this minus sign. Cos theta diagonally the same, sin theta diagonally same, but you have only minus here. Now let's see how we actually get. Now what is x? X is equal to x into cos theta minus y into minus sin theta. Is it not? This is what I've taken. Now what we have to do, x into cos theta. Then when you are taking y, it is y, x into sin theta plus y into cos theta. Let's see how do we write that. X into cos theta, x cos theta minus y into sin theta. That is equal to what? Small x, original coordinates. Same, y is equal to x into sin theta plus y into cos theta. This is how you can find from this table what is original coordinates. Then let's see how do you find new coordinates. Capital X is equal to small x into cos theta plus small y into sin theta. That's how we just take this. Then y also equal to xy, y into minus sin theta and cos theta. This is same. I'm just taking the second column. Now x is equal to what I have to do? X into cos theta plus y into sin theta. Because there is no sign, it is understood plus. Here sign is there, x into minus sin theta plus y into cos theta. Just multiply them. X is equal to x cos theta plus y sin theta. Capital Y is equal to minus x sin theta plus y cos theta. I repeat, see, if you want capital X, x into cos theta plus y into sin theta, x into cos theta plus y into sin theta. If you want capital Y, x into minus sin theta minus x sin theta plus y into cos theta. Let's see. So small capital X is x cos theta plus y sin theta. Capital Y is minus x sin theta plus y cos theta. Isn't it easy, students? Yeah, you can remember that easily. Now, when we know how to remember, how to actually solve the questions, this table is going to help us. Let's apply. Let's check whether we can use this table in solving the problem or not by taking an example. See, when the axes are rotated through an angle 30 degrees, find the new coordinates of minus 2 comma 4. What did we do in our earlier session? First we analyze, understand the question. What is given? Find the new coordinates. So what is given? Old original coordinates are given. Axes are rotated to an angle 30 degrees. That means theta is 30 degrees. Given theta is 30 degrees, and then original coordinates are given. What are we supposed to find? We're supposed to find new coordinates. Let's get our table. And capital XY is how much, isn't it? Now, what is capital X? X cos theta plus y sin theta. Capital Y minus x sin theta plus y cos theta. That's what we are going to take. Okay? X is equal to x cos theta plus y sin theta. Y is equal to minus x sin theta plus y cos theta. Let's substitute. X is equal to, what is x value? Original minus 2 cos theta is how much? 30 plus y is 4 into sine 30 degrees this is. Y is equal to, x is equal to, what is cos 30? Root 3 by 2. Sine 30, 1 by 2. Okay, students. Now, y is equal to minus x sine theta plus y cos theta minus x is how much? Okay. Let me just correct this 30 degrees. It's not 300, it is 30 degrees. Yeah, this is our question. Given is theta 30, xy we have found. We have taken the table and then This is all done. I just wanted to change that 300 to 30 degrees, right? Sometimes, no, the computer doesn't listen to me. I know you will listen to me. Right, students? Cos 30 is root 3 by 2. Sin 30 is 1 by 2. Please recollect what all you have learnt in trigonometry of class 10. You all know all these values, right? So now after simplification, I can cancel out this minus 2 and 2 and 2, 2 ones. 2 ones are 2 twos. So what do I get? Minus root 3 plus 2. That's the value of capital X. Now capital Y is equal to minus of minus 2. X value is minus 2. It's already minus here. Sin 30 plus 4. Y is 4 cos 30. Plus, minus of minus, that will become plus. 2 ones are 2 twos are, and 2 ones are 2 twos are. When cos 30 is root 3 by 2, cos 30 here also will be root 3 by 2. Sin 30 will be 1 by 2. No new values. 2 ones are 2 ones are 2 ones and 2 twos. So minus of minus you get plus 1 plus 2 root 3. So we can rearrange and write this integer first. So x comma y can be written as 2 minus root 3 comma 1 plus 2 root 3. What are these? These are the coordinates of the point with respect to the new system. Oh, we already discussed that this table can be used in order to find the original coordinates or in order to find the new coordinates. Now let's see an example where transformed coordinates, that means coordinates with respect to the new axis are given, but we have to find the original coordinates. Let's take another example and try to find out. When the axes are rotated to an angle 60 degrees, the new coordinates of a point are 3, 4. Find the original coordinates. So you have to find small xy. What's given? New coordinate 3, 4. And rotated to an angle 60 degrees. So theta is 60 degrees. And capital XY is equal to 3, 4. We have to find small xy. Here comes our table, which is the same table that we have used for earlier question to find the new coordinates. Now, what equation we have to take? X small x is equal to x cos theta minus y sin theta. Small y is equal to x cos sin theta plus y cos theta. That's what we're going to take. What is x value? Capital X is 3, capital Y is 4. Theta is 60. Let's substitute. X is equal to 3 cos 60 minus 4 sin 60. And 3 into cos 60 is 1 by 2. Sin 60 is root 3 by 2. Isn't it, children? Have I written it reverse? No. There, cos 60 is 1 by 2 and sin 60 is root 3 by 2 only. Now simplify. This is 3 minus 4 into root 3, 4 root 3. As we have denominator 2 in both the terms, I am taking the common denominator 2. Let's look at the value of y. X is 3 sin 60 plus 4 cos 60. What is sin 60 value? Here we have, that's root 3 by 2, cos 60 1 by 2. So 3 root 3 plus 4 into 1, 4 by same denominator, that's why the denominator is 2. What did we find now? We have found the new coordinates. The original coordinates. When new coordinates are given, we are finding the original coordinates. Therefore, x comma y is equal to 3 minus 4 root 3 by 2 or comma 4 plus 3 root 3 by 2. This 3 root 3 by 4, I am just writing it as 4 plus 3 root 3 by 2. Then we have found new coordinates, we have found original coordinates. What next, students? You all know what next? We are going to find an equation. When the original is the equation given, we are going to find the transformed equation. When transformed equation is given, we will get back the original equation through the rotation of axis. Let's see that through an example. When the axes are rotated through an angle pi by 6, find the transformed equation of the given equation x square plus 2 root 3 xy minus y square is equal to 2a square. What is the change that you notice here? In this question, the angle is not given in terms of degrees. It is given as pi by 6. Nothing to worry, children. You must be knowing also, your teachers must have discussed, but I'll revise that once again. Pi radians are nothing but 180 degrees. So 180 degrees by 6, 6 ones and 6 3, 30. So pi by 6 is nothing but 30 degrees. What is given? Original equation given. How do we know? We are asked to find the transformed equation. When you have to find transformed equation, what does it mean? The given one is already original equation. So what's given here? Axes are rotated through some angle, then the equation of a curve changes from fx comma y to f of x cos theta minus y sin theta, and y value x sin theta plus y cos theta. Have we not seen this in the table? Same. We have used the same now in previous question also. Okay. Theta is pi by 6. What is pi by 6? I told you already, it is 30 degrees. Pi is nothing but pi radians is equal to 180 degrees. Here we have x is equal to x cos theta minus y sin theta, and y is equal to x sin theta plus y cos theta. So x cos 30 pi by 6 minus y sin pi by 6. Y is equal to x sin pi by 6 plus y cos pi by 6. Cos pi by 6, cos 30 value, how much, students? Cos 30, root 3 by 2, you're right. What is sine 30? 1 by 2. So we write. Do we know the value of capital X and capital Y? We do not know. So we are leaving them as they are, and we will substitute that in the equation in order to find the transformed equation. That's nothing but, again, y, x into 1 by 2 plus y into root 3 by 2. X into root 3 is root 3x minus y into 1 is y. 2 and 2 denominator is the common denominator here. Then y is equal to x into 1 is x plus y into root 3. We write it as root 3y. 2 is the common denominator. What are these? These are the coordinates in the form of nu. Now, here what do we have in the given original equation? Small x, small y. We are going to replace them, substitute them with their values in terms of new coordinates. Let's do that. This is the value that we got. What is the given equation? X square plus 2 root 3xy minus y square is equal to 2a square. Now I am going to substitute, students. Let's observe carefully. What is x value? X value is root 3x minus y by 2 whole square plus 2 root 3 into x value root 3x minus y by 2 into y value x plus root 3 y by 2 minus y square x plus root 3 y by 2 whole square is equal to 2a square. Now what is this 2? But when you square it, what are you going to get, students? Are we not going to get 4? We will of course get 4. And how about the denominator here? 2 twice, 2 2s are 4. Again 2 square 4. So all the three terms have a common denominator. So I'm just taking that 4. And in which form is it? It is in which form? A minus b whole square. A square. When you square root 3 square is 3 and 3. Square and root get cancelled. 3x square minus 2ab. 2 into root 3x into y. 2 root 3xy plus b square. Y square. This 2 root 3 is left like that only. I'm multiplying. Just go through carefully. This is simple multiplication you have done so many times. Because the numbers are too many, let's go slowly. Root 3x into x, root 3x square. Root 3 in x into root 3y. First numericals, root 3 into root 3, 3. X into y, xy. Then minus y into x, minus xy. Minus into plus, that's minus y into root 3y. Root 3 into 1, root 3y into y, y square. Then minus is there before the bracket. This is nothing but a plus b whole square. Let's see, the a square is x square. Expansion is this. 2ab, 2 into x into root 3y. So first numericals, 2 into root 3, x into y, xy. This is 2ab term plus y square. Root 3 whole square is 3y square. By 4, by 4, by 4. Can I take by 4 to the right side? And try to eliminate these brackets by multiplying. Let's see. 3x square minus 2 root 3xy plus y square. I just left it like that only. Here you need to understand this term. 2 root 3 into root 3. Root 3 into root 3? Root 9. That is 3. 2 3s are 6. 6x square. 2 root 3 into 3. 3xy minus xy. I have simplified both the terms here. 3xy minus xy, 2xy. 2 2s are 4 root 3xy. Minus into plus minus. Root 3 into root 3. 3. 3 2s are 6y square. Minus, this is same as it is. X square plus 2 root 3xy plus 3y square is equal to, why are we getting here 8a square? You all know we brought this denominator which is common in all the three just to the right side. 4 2's 8a square, isn't it? Now you have x square term here, x square term here, x square term here. Then xy term here, xy term here, xy term here. Y square term here, y square term here, y square term here. Let's see. I've written the equation again here, and then I'm going to simplify that. 3x square plus 6x square minus x square, y square minus 6y square plus 3y square. This is plus 3y square. Then you have we are just simplifying and bringing all the terms to one simplification form. Just see that simplification again. 3x square plus, this is the original step that we have. I brought all the x's. 3x square plus 6x square minus x square, y square minus 6y square. Oh, I'm sorry, that was minus 3y square only, right? See children, here minus into plus, minus 2 root 3 minus into 3y square minus y square minus into plus minus 3y square. Then all this minus 2 root 3 xy, 4 root 3 xy minus into plus minus 2 root 3 xy, we brought it, is equal to 8 square. What do they get cancelled? Minus 2 root 3 minus 2 root 3 is how much? Minus 4 root 3 and plus 4 root 3. This term entirely get cancelled. These 3 get cancelled. 3 plus 6, 9 minus 1, 8x square. Minus 6 minus 3, minus 9 plus y, minus 8y square is equal to 8a square. Let us see now 8 common, x square minus y square, bring it to this side, 8 by 8 you can cancel. X square minus y square is equal to a square is the required transformed equation. We were given with the original equation, now we found the transformed equation. Again, same thing, when transformed equation is given, we can similarly find the original equation. Let's check that once with an example. When the axes are rotated through an angle 45 degrees, the transformed equation of curve is 17x square minus 16xy plus 17y square is equal to 225. This is the transformed equation. You are asked to find the original equation. So given is theta is 45 degrees. 17x square minus 16xy plus 17y square is the transformed equation. Have you noticed, children? What did I do here? I just replace the small xy with the capital XY because it's a transformed equation for us to make the calculation part easier, right? Now, in order to find the original equation, what is the formula that we have to use? Capital X is x cos theta plus y sin theta. Same, you can recollect the table. Capital Y is equal to minus x sin theta plus y cos theta. How much is theta? 45. Let's substitute that. X cos 45 plus y sine 45. This is degree. I'll not waste your time. You please consider this as degree. Then y is equal to minus x 45 plus y cos 45. X into cos 45 is 1 by root 2. Sine 45 is also 1 by root 2. Sine 45 is 1 by root 2. Cos 45 is 1 by root 2. So what are we going to get? We are going to get x plus y by root 2 in place of capital X, minus x plus y by root 2 in the place of capital Y. We are going to substitute these values of capital X and capital Y in the given transformed equation in order to get what? Original equation of the curve. Let's take the original transformed equation, and capital X is x plus y by root 2. Capital Y is minus x plus y by root 2. 17 into x square, x plus y by root 2 whole square, minus 16 into x value into y value, x plus y by root 2 into minus x plus y by root 2 plus 17 of y square minus x plus y by root 2 whole square is equal to 225. Don't be confused, or don't be like taken back. These are all simple a plus b whole square, a minus b whole square formula. Root 2 and square will get cancelled. Nothing to worry. If you square the root 2, what are you going to get? 2. What is root 2 into root 2? Again 2. Here also 2. Same denominator in all the three terms. Is it not? That's what? That is 2. We will expand x plus y whole square. A square plus 2ab plus b square. We will take this. If you notice this is x plus y. Can I say this is y plus x also? Yes, I can say. X plus y can also be said, taken as y plus x into y minus x. Y square minus x square. A plus b into a minus b form. Isn't it? Plus 17 into this is a minus b whole square. A square minus 2ab plus b square is equal to 225. Everywhere the denominator is 2. So let's take 1 by 2. 17x square, 17 2's, 34xy, 17y square minus 16 into minus x square, minus into minus, plus 16x square minus 16y square plus 17 into x square, 17x square, 17 2's, 34 plus into minus, minus 34xy plus 17y square is equal to 225. What do we have here? We have 2 here, and here plus 34xy minus 34xy, they get cancelled. 17 plus 16, how much? 33. 33 plus 17, 50x square. 17y square minus 16y square, 1y square, 1 plus 17, 18y square. So 1 by 2 into 50x square minus 18y square is equal to 225. Can we not simplify this? 50 by 2 is 25, 18 by 2 is 9. So 25x square minus 9y square is equal to 225. This is the required original equation. Students, you will learn what kind of a curve does it represent. Is it going to be a circle? No. Is it going to be a parabola? I don't think. I think this will be an ellipse. You will be learning about all these equations in your senior inter class, right? Now, when the original transformed equation is given, we found the original equation also. So far, we've been dealing with rotation, and when the rotation takes place, how the original equation gets transformed and how the original coordinates get transformed. If we are given with original coordinates, can we find transformed coordinates? Yes. If we are given with the transformed coordinates or equation, we have also found the original coordinates or equation. Now we have another interesting concept called, see, this is an equation ax square plus 2hxy plus by square is equal to 0, where a is not equal to b. Do you remember in our previous class we have taken a second degree equation which has first degree terms also. That means what? You had 2g plus 2gx plus 2fy plus c. Here we are taking a homogeneous second degree equation in standard form where a is not equal to b, and show that the axes are to be rotated. Now, In order to remove this xy term, how much angle should we take and rotate the coordinate axis is the question. And we are going to prove that that angle is half tan inverse of 2h by a minus b. How? Let's see. Show that the axes are to be rotated to an angle of half tan inverse to h by a minus b, so as to remove the xy term. What is the xy term? 2hxy. From the equation ax square plus 2hxy plus by square is equal to 0 if a is not equal to b, and through an angle pi by 4 if a is equal to b. When A is not equal to B, the angle is this. When A is equal to B, the angle is pi by 4. Again, I told you what is pi. Pi radians are equal to 180 degrees. 180 by 4 is 45. Let's see how do we show this. How do we prove this? If the axes are rotated through an angle theta, then we know what is small x is equal to x cos theta minus y sin theta. Small y is equal to x sin theta plus y cos theta. Let us take the given equation and how it gets transformed. The given equation transforms as a into x value x cos theta minus y sin theta whole square plus 2h into x value x cos theta minus y sin theta, y value x sin theta plus y cos theta. We are multiplying x into y plus by square. I have taken y value x sin theta plus y cos theta whole square. Everywhere you need to have a little patience. You can simplify all this. You can square the a minus b whole square. You can multiply these terms. You can square this, isn't it? You can actually, what is that we are asked to do? We are asked to do the remove the xy term. So in order to remove the xy term, what do we have to do? We can simply equate the coefficient of xy term to 0. We need not take all the simplifications, right? So what am I going to do here is, if I multiply expand a minus b whole square, what do I get? Do we have xy term? 2ab term is there. What is the 2ab term? 2xy cos theta sin theta. It is minus, so minus 2ab term. Here when I am multiplying xy term, what do I get? X into x, I am not interested because x is square term. X into cos theta, y into cos theta, xy cos square theta. Is it not? X into y cos square theta. Now minus y sin theta, x sin theta, minus xy sin square theta. Two more terms we got. And in a plus b whole square also you have plus 2ab plus 2xy sin theta cos theta. Let's see. Let us write only the terms containing xy. That means in order to remove the coefficient, first I will write down all the terms that are included in xy. That means xy terms containing xy. Let's see. A into, I told you, minus 2xy sin theta, minus 2ab from here, 2h into xy cos square theta, minus yx or xy sin square theta, plus b into 2xy sin theta cos theta. I have to equate the entire term to 0. Xy cannot be 0. Obviously, the coefficients will become 0. Here is the step. I have written the same step again here. Let's take 2xy common. Now here, children, what do you have here? You have minus a. What is here? Plus b. Can I not write it as b minus a? You can write it as minus a plus b, or you can write it as b minus a. Both are same. Now, when I am taking 2xy outside, this is b minus a. Why b minus a am I taking? Here is a term containing sin theta cos theta. Here is a term containing sin theta cos theta. I can just take sin theta cos theta. 2xy, 2xy I have already taken common. What is left here? B. What is left here? Minus a. So I am just taking the like terms in terms of xy in terms of sin theta cos theta and writing them as single term. Once again, 2xy, 2xy common. Sin theta cos theta, sin theta cos theta common. What's remaining here? B. What is remaining here? Minus a. So b minus a sin theta cos theta. The next term also has xy and xy. Just bring them out. 2h xy, 2xyh into what is here, cos square theta minus sin square theta is equal to 0. Students, this xy cannot be 0, 2 cannot be 0, isn't it? Xy cannot be 0. The coefficient of xy term should be 0. That means b minus a into this 2 is there, 2 sin theta cos theta plus 2h into cos square theta minus sin square theta is equal to 0. What is 2 sin theta cos theta? Do you remember anything, students? Oh, isn't it sine 2 theta? You're right. This is sine 2 theta. What is cos square theta minus sin square theta? This is cos 2 theta. Let's write it as 2h into cos square theta minus sin square theta is equal to, bring this to the other side, minus b, minus of b minus a, 2 sin theta cos theta, and then simplify. 2h cos square theta minus sin square theta cos 2 theta, minus of b minus a will become a minus b, minus into minus plus a minus b, 2 sin theta cos theta is sin 2 theta. Here you have cos 2 theta, here you have sin 2 theta. Can we not take sin theta by cos theta? What do you get? Right, it is sin tan 2 theta. So sin t2 theta by cos 2 theta is tan 2 theta, that is equal to 2h, and a minus b is brought to this side. Denominator is a minus b. Why this condition a minus b? A is not equal to 0. If a is not equal to b, if a is equal to b, the denominator will disappear. That's why only if a is not equal to b, tan 2 theta is taken like this. If a is equal to b, this entire term will become what? 0. 0 into anything is 0. So 2h cos theta is equal to 0 if a is equal to b. Let's simplify it further. Now 2 theta is equal to tan inverse of 2h by a minus b. Students, you will learn about how to convert this. Tan x is equal to y. Tan inverse of y will be equal to x. These are called inverse trigonometric functions. You will learn them in your later classes. When you are going to learn about inverse trigonometric functions, you will understand this clearly. You just recollect what you have learned in functions. If x has an image y, then what is x called? The pre-image or inverse image of y, isn't it? So if we, that under the tan function, what is the image of 2 theta? This is. So what will be the pre-image or inverse image of this? Will be the previous term. Just blind a symbol I am giving for you to understand for this. Now. In your future classes, you will learn how to convert and expand the inverse trigonometric functions also. This is 2 theta is equal to tan inverse 2h by a minus b. Cos 2 theta is 0, 0 by 2h. When is cos 2 theta 0? When is cos 0? Cos is 0 when theta is 90. So 2 theta is 90. 90 is nothing but pi by 2, 180 by 2 if a is equal to b. So theta is equal to 1 by 2. This 2 comes to the other side. 1 by 2 tan inverse 2h minus b. If a is not equal to b, then theta is equal to, if I bring 2 here, what will happen? Pi by 4 if a is equal to b. Students, this result can be used in order to solve problems, and mostly this is used in solving your, even in your objective type questions also. Right? Now, this is when we have to remove xy term from the given equation by a rotation. Through how much angle you have to rotate the axis? If a is not equal to b, it is half tan inverse 2h by a minus b. If a is equal to b, the angle is pi by 4, nothing but 45 degrees. Now, so far we have learnt about only rotation. In earlier class, we have learnt about translation. Now let's see what is translation come rotation. Rotation come translation. Is it both are taking place? Let's see. These are coordinate axes which you are familiar with. A point, coordinates are x, y. Then what are we doing? We are translating. That means shifting the origin. At the same time, we are also rotating it. So the new coordinates are again capital XY. Old coordinates are, original coordinates are XY. So what is h comma k? From 0, 0, the origin is shifted to h comma k, right? So new origin is h comma k. What is happening? The axes are getting translated as well as rotated, isn't it? So we know x is equal to x cos theta minus y sin theta. But what we have learnt in translation, do you remember, students? Small x is equal to capital X plus h. Capital X is this plus h. Small y is equal to capital X y plus k. We are just adding h and k because the axes are also getting translated to a new origin, right? So we use this in order to solve, actually simplify the questions involving both translation and rotation. Shall we see an example? Right. What is that? That's a theta. Theta is the rotation. Now let's take an example and apply this formula. When the origin is shifted to -2 comma -3 translation and the axes are rotated through an angle 45 degrees rotation, both are taking place. Find the transformed equation of 2x square plus 4xy minus 5y square plus 20x minus 22y minus 14 is equal to 0. What is given? H comma k. Remember, translated when the origin is shifted. New origin is h comma k. Theta is 45. When you are asked to find the transformed equation, clearly understood that what is given is the original equation. Let's look at the solution, students. H comma here, h comma k is -2 comma 3. Theta is 45. And let capital X, Y, comma be the new coordinates of any point in the plane after transformation. So how do we find small x, y? We use the formula. Small x is equal to x cos theta minus y sin theta plus h. Small y is equal to x sin theta plus y cos theta plus k. Substitute cos 45, sin 45. What is h value? -2. What is k value? -3. X sin 45 plus y cos 45 minus 3. We know sin 45 or cos 45 are equal. What is value? Right, it is 1 by root 2. So x is equal to capital X 1 by root 2 minus small y, capital Y 1 by root 2 minus 2, and small y is equal to x by root 2 or x into 1 by root 2 plus y into 1 by root 2 minus 3. Then capital X minus y by root 2. This minus 2 is there. Y is equal to x plus y by root 2, same denominator here and here, minus 3. So we are going to substitute the original coordinates x comma y in the original equation in order to get the transformed equation. So what are we going to substitute? Substituting the value of small x and y in the given equation. Let's take the given equation. Yes, what are the values of x and y? Let us substitute x minus y by root 2 minus 2 and y whole square plus 4 into x minus y by root 2 minus 2 into x plus y by root 2 plus minus 3 minus 5y square. 5y is x plus y by root 2 minus 3 whole square plus 20 into x minus 22 into y minus 14 is equal to 0. What did I do, children? I have just substituted the values of small x and small y, original coordinate values, in terms of new coordinates. Again, a little lengthy calculation. Don't worry, I'll make it easy for you. See, 2 is like that only. This is a minus b whole square, a square. Root 2 whole square will become 2. B square is 4 minus 2ab. 2 2s are 4 into x minus y by root 2 plus 4 into x plus y into x minus y, x square minus y square. Root 2 into root 2, 2 minus 3 into x minus y by root 2 minus 2 into x plus y by root 2 minus into minus plus 2 3s are 6 minus 5 into x plus y by root 2 minus 3 whole square, a minus b whole square, a square, root 2 whole square, 2. B square minus 3 whole square is 9. Minus 2ab, 2 into 3, 6 into x plus y by root 2. Then here, what is this? In the denominator you have root 2. In the numerator you have 10. I am simplifying this. 20 is nothing but 10 into 2. So 10, 2 by root 2, is root 2. Why? 2 can be written as root 2 and root 2. 1 root 2 will get cancelled. So 10 root 2 into x minus y minus 20 plus into minus 20 into 2 is 40 minus 22 again is 11 into 2, 11 root 2 into x plus y minus into minus plus 22 into 3, 66 minus 14 is equal to 0. We will still further simplify this till we have the equation in the standard form. See here 2 into x minus y by 2 whole square. 2 2 will get cancelled. 2 4s are 8. 2 2s are 4 root 2. 2 4s are 8. 8 by root 2, 4 root 2. Plus into minus 4 root 2 into x minus y. Plus 4 into x minus y, x square minus y square by 2. 2 ones and 2 twos. 2 into x square minus y square. 4 threes are 12. 12 by root 2, 6 root 2. Plus into minus 6 root 2 into x minus y. 4 into minus 2, 8. 8 by root 2, minus 4 root 2 and x plus y. 4 6 are 24. Minus 5 into x plus y whole square by 2. So 5 by 2. You cannot simplify 5 with 2. You will get 2.5, isn't it? We will leave it like that. X plus y whole square. Minus 5 into 9, minus 45. Minus 5 into minus 6, minus 30. 30 by root 2, 15 root 2 xy. This is minus into minus, so it has become plus 15 root 2 xy. What is there here? 10 root 2 into x minus y. I have written it as it is. Minus 40 minus 11 root 2 into x plus y plus 66 minus 14 is equal to 0. Now children, what is there here is a lengthy equation, but there are so many common or like terms. Let's see x minus y term, x minus y here also, x minus y here also. Minus 4 root 2 minus 6 root 2 is minus 10 root 2. This is plus 10 root 2. So don't they get cancelled? Yes, we can cancel them because plus 10 and minus 10 will become 0. Minus 4 root 2 minus 6 root 2 minus 10 root 2 plus 10 root 2 will become 0. Then we have minus 4 root 2 plus 11 root 2 minus 15 root 2 plus 15 root 2. These two terms also get cancelled. What are left? See x minus y whole square. All these terms I'm going to write again. X minus y whole square 8 and 2 times x square minus y square plus 24 minus 5 by 2 x plus y whole square minus 45 plus 66 minus 40 is here plus 66 minus 14. I'll take this term again. You can do all these calculations. I'm just, should I leave it blank? I've given you the transformed equation. No, I'll just quickly go through. You can do these calculations. This is going to be your final answer, but see the simplification steps quickly. You would solve it yourselves. If you have any doubt, you can revisit and check the slide. Okay, see, these are the simple calculations. I've expanded x minus y whole square, I've expanded x plus y whole square and put all the like terms together. Then all the numericals, I've added all the positive terms 98 and negative terms minus 99, and then took LCM with 2, right? So 6x square minus 5x square, x square minus 2y square minus 5y square minus 7y square, 10 and 4 both minus 14xy minus 2 is equal to 0. That is the required transformed equation. Children, even though the calculations are lengthy, they are very simple calculations involving just a plus b and a minus b whole square and regrouping, rearranging the like terms. So I hope you will not find it difficult. Now it's time for you to take up a few questions for practice. They're again the same questions based on the models that we have solved. When the axes are rotated, find the new coordinates, right? When the axes are rotated through an angle 60 degrees, the new coordinates are given, find the original coordinates. Very simple questions. You can quickly do them just immediately after the class so that you will not leave anything pending. Should I wait for a while for you to take the screenshot of this? Please do, children. When the axes are rotated through an angle pi by 6, Find the transformed equation of 3x square plus 10xy plus 3y square is equal to 9. Thank you so much. Thank you, children. With this, we conclude transformation of axis and wait for a few more sessions of coordinate geometry, and then you will also have one more interesting sessions. Thank you, madam.
Yeah, good morning, madam.
Good morning, ma'am.
Late Latif, you have to pardon me.
Yeah.
And
Thank you, Sreedevi
I know
ma'am.
you called me, then I saw you. Madam, that
Thank
was a
you.
great session, madam.
thank you, ma'am.
Sai Ishwari ma'am, please give your concluding remarks.
Oh, still we are on live, huh? Okay, sorry. Okay, students, it's great that you have heard about translation and rotation of axis till now. That was a great session by Sreedevi madam. And this would help you more in your higher studies when you really read about Einstein's E is equal to mc square equation, where you will literally know how this would help in physics also, and the application part you would learn in physics. Okay, so for now, madam has given you an elaborate session of translation as well as rotation of axis. Once again, to revise, translation is shifting the origin from 0, 0 to some other point, and rotation of axis is not shifting the origin, but it is rotating the axis. Hope you have understood well about this. And in the coming sessions, we would be looking into more of 1B, mathematics 1B sessions. And thank you, madam, from all the viewers' point. You have given a great session. Thank you, madam.
Thank you, ma'am.